This video will demonstrate a UGV behavior called multiple follow. The circles represent regions which are based on range. Inside the smaller circle is the region where users will be considered to be at a normal distance. Between the two circles is the region where users will be considered far from the UGV. Outside the larger circle is the region where users will be considered to have abandoned the UGV. Currently, there are two pedestrians inside the far region. Note that since the UGV is now following two persons, radius of the circle have been increased to accommodate both persons. In this behavior, the UGV needs to calculate where it should set its destination with regards to the two pedestrians. Imagine a line to pass between the two pedestrians. At the midpoint of this line, imagine another line perpendicular to the first line being formed. At the top of this perpendicular line is where the UGV will set its destination. This is done to allow the UGV to follow the two persons at a safe distance. Since the UGV is now following two persons, the algorithm in determining where the UGV should go and at what speed is more complicated than following just one person. Let us begin by considering a simple case where both users will be inside the normal and far region. If both pedestrians are inside the normal region, the UGV will move at half speed. If both pedestrians are inside the far region, the UGV will move at full speed to catch up. Whenever one pedestrian is in the normal region, while the other pedestrian is in the far region, the UGV will follow the pedestrian which is inside the normal region. While following the closer person, it will still keep track of the location of the other pedestrian. If the other pedestrian moves back so that the two pedestrians are inside the same region, the UGV will then follow at a safe distance behind the two. The UGV will move at full speed if they are both at the far region and at normal speed if they are inside the normal region. As long as either pedestrian is within the larger circle, in other words, no pedestrian is in the abandoned region, the UGV will keep track of the location of both pedestrians. If, however, one pedestrian moves until he or she is in the abandoned region, the UGV will switch its behavior. Instead of multiple persons following behavior, it will implement a single person following behavior. The location of the pedestrian which has abandoned the UGV will no longer be tracked. The UGV will then only focus at the closer pedestrian. Even if the other person returns to the UGV will not implement the previous behavior. This concludes the UGV's multiple persons following behavior.